right, you guys. So, like I said, I just need you to write down these notes as I go along and snap a picture of them and upload them into the Digital Learning Day 2 Dropbox. So, today we're going to be talking about cladograms and phylogenetic trees. And as we go through the video, just pause it. And if I talk about like a diagram or something, I really need your full attention. So I need you to like actually pause the video, write down your notes, and then wait for me to explain. Okay. So cladograms and phylogenetic trees. These show evolutionary relationships between different organisms. We've actually looked at several different ways we've looked at several different cladograms and phylogenetic trees in our first two evolution units, but we never identified how to read them. Y'all were just looking at them. So I think that you'll find this pretty easy because we've kind of done it already. But these things can be used to identify shared common ancestors and shared traits among organisms. And here's some vocabulary that goes along with these. So nodes. These represent the common ancestors for following organisms. They do not apply to previous organisms. And on a cladogram or a phylogenetic tree, unique traits are developing between the branches, and they apply again to following organisms and not previous organisms. So right now would be a time where you should pause this video because I'm about to actually pull up a cladogram and talk y'all through the vocabulary that I just gave you. So here is a cladogram, and this is showing an evolutionary relationship between all of these organisms. So from a hagfish all the way to a chimpanzee. Down here in this area, we would call this the LUCA, L-U-C-A, the last universal common ancestor. You need to write that down, LUCA, L-U-C-A. So this is like the very first organism, and then we go through and we see how the chimpanzee has evolved from the LUCA. So these little guys down here are the nodes that I was talking about. These are representing the common ancestor for the following organism, not the previous ones. So on a test, these nodes down here would be labeled like A, B, C, D. And I would say identify the LUCA between the lizard, pigeon, mouse, and chimpanzee. And you guys would come, you would look at your cladogram, you see lizard, pigeon, mouse, and chimpanzee. So you'd go back, and right here would be the node that represents that previous common ancestor. So again, this is the common ancestor for the following organisms, not the previous ones. Following, not previous. So same thing goes on with the traits. So the organisms that have the traits are following where the trait is on the branch. So for example, lungs. You see this one right here? It says lungs. So the only organisms that have lungs on this cladogram are the salamander, the lizard, the pigeon, the mouse, and the chimp. The perch and the hagfish do not have lungs because they are previous on the tree or on the cladogram. I might ask you guys a question like, which organisms have claws or nails? And you would go look at the claws or nails branch right there, and you would say lizard, pigeon, mouse, and chimp. Okay? I want you guys to drop me a question on the Padlet if that is not making sense, and we can schedule a time to chat about it. Okay? Next up, this is another way. This is considered to be a phylogenetic tree, where this is a cladogram, this is a phylogenetic tree. You read them the same way, they're just kind of laid out differently. So the lines are representing a series of ancestors and evolutionary changes for specific organisms. So what I mean by that, let's say organism B right here. Follow along with my cursor as I just go through the evolutionary line of organism B. So here's the first part, second, third, and fourth. Down here would be our LUCA, remember, last universal common ancestor, L-U-C-A. And then these little branches where they branch apart, those are considered to be the nodes. Okay? And then right here is where the specific traits for the organisms would be. So over here, LUCA and LUCA branched into this organism and organism E. And then this organism branched into this one and this one. And then those two separate ones branched into A and B and C and D. So, phylogenetic tree, cladogram. If you guys are struggling with reading these things, please, please, please drop me a question on the Padlet. What I want you to do as far as notes goes, I want you to put down this phylogenetic tree in your notes, just a quick sketch of it. It's super simple. That's why I gave you this one. And remember that you're going to be snapping a picture of this, so I will see if we have done it or not. And I'm thinking about giving y'all a classwork grade for your notes yesterday and your notes today. So I really need you to do it. Okay, so this is something that's really fun. If we were actually in class, I would show you guys the full one. So scientists have created a phylogenetic tree of every single organism that we know about on Earth. And if we were in class, we could zoom in and we could actually see everything. But if we were to zoom in, you would see Homo sapien right here. And I would ask you guys who's the closest to us on the tree. And as we already know, it's the chimpanzee. So they are actually right beside us. So if you guys have a chance and you want to go, you're interested in looking it up, you can look up phylogenetic tree of life and it would pull up the one that it has every single species on Earth that we know about, from bacteria to archaea, all the way to the kingdom Animalia, which we are. All right. So I will see you guys tomorrow.